Previously, I explained to you the meaning of the nth term of a sequence. Now today we're going to derive a formula for it such that when we are asked to find any term of a particular sequence, all we'll need to do is to simply apply the what we're given into the formula and then we'll get the answer. Let's use this one for example. Let's take a sequence like this: 3, 5, 7, 9, and so forth. Now this is a very easy sequence and you probably know the next term and even the term after it, right? But assuming we're asked to find the 500th term or the 208th term, we need to have a relation such that we plug it in and we just get the answer. So how do we do that? Well, let's consider some important details here. We notice that as we add 2 to each number, we get the number immediately after it. So if I say 3 plus 2, it gives me 5. 5 plus 2 gives me 7, and so forth. So from there we can notice a pattern, a successive addition of 2. But let me even start by labeling the positions of these numbers. This is first, this is second, this is third, and this is fourth. So what we are looking for is the nth. So what would be in the nth position? I want to arrange it vertically. So the first position took on 3. The second is 5. The third is 7. And the fourth is 9. Okay, this is my fourth, which is 9. Now, how did I get 3? Well, we could say that I got 3 by simply saying 3 plus 0. And how did I get to 5? Well, we got 5 by simply adding 2 to 3. That gave us 5. Now, how did I get 7? Well, we got 7 when I simply added 4 to 3. And we got 9 when I added 6 to 3. I could rewrite this in another way by further extending it. Let me begin from this one. So this is as it is, right? 3 plus 2 gives us 5. Now let's go to this one. So I want to spread it apart. So 3 plus 2 plus 2. Now that gave us 7. And 3 plus 2 plus 2 plus 2, that gives us 9. So what do you notice in all of these? A certain number is repeated. And what's that number? 3. Now, when I wrote it in another form, there's another number that was actually repeated, and that number is 2. It's easy for us to know where this 2 came from. It came from the successive addition that we have in the sequence here. That helps us to know what the next term is. So I want to now rewrite all these 2's here into something that even looks simpler and much easier to figure out. So how do I do that? So instead of having 3 plus 2, I'd rather decide to write 3 plus 2 times 1. Well, this will still give me 2, so I'm still going to get 5. And here, instead of having 2 plus 2, which is 4, I'm going to write it as 2 times 2. And in this next one, I'm going to write this as 2 times 3. So this is going to be bracket 2 times 3. Okay. So going back to the first one, how could I make it look like the others? Well, I could also write this as, sorry, let me put my arrow. I could also write this as 3 times, open a bracket, 2 times 0. Do you notice a pattern? Well, we have all 3's here. We have all 2's on this side. And here we have 0, 1, 2, 3, moving in sequence. So what can we deduce from this? If I decide to call my positions n, and I call my first term, because the first term was reflected in all the numbers. So let's say I call it A. And then I decided to call the 2, which was successively added to each of these numbers to get the next one. Let's say that I call it D. So I have my A here, and I have my D here, and I have my N as the positions. So what could I call this one? 0, 1, 2, 3. So notice a pattern. If this is first, this number here is 0. If this is second, this number here is 1. If this is third, this number here is 2. And if this is fourth, this number here is 3. So if these positions are n, it means this number here simply means n minus 1. So 1 minus 1 gives me 0. 2 minus 1 gives me 1. 3 minus 1 gives me 2. And 4 minus 1 gives me 3. So our nth term has emerged. The formula has emerged. Sorry, we have, this is supposed to be a plus. Good. So our nth term has emerged, and that is given by what we have here. We've identified them by the symbols A, D, and N. So what is the nth term? It means that the nth term of a sequence is given as A plus, open a bracket, N minus 1 times D, where A represents the first term. D represents the common difference. And then your N represents the position under study. So that is how simple it is to derive the relation for the nth term of an AP. So we're going to solve some questions, and we'll see how we can use this formula to get to the correct answer. Thank you very much.